Good evening, minions. Welcome, we enthusiasts, to this very special marathon session on magnetic effects and moving charges and current. Welcome, welcome, welcome. Today, we are going to see a lot about magnetic field and how magnetic field affects charges and also wires carrying current. So let's talk about a lot about magnetic forces, and we are going to see all the details about it, right from torque, Lorentz forces, and so many other things. So guys, get ready for this very special marathon session with Shreyas, your master teacher for physics and also the anchor for this channel. Guys, you know what is the speciality of a marathon session and why do we conduct a marathon session? Do you actually know the reason? How many of you actually know the reason? Hello Jumna, Fida, Kirito, Anusha, Anish, Science Priya, Sanjukta. Hello aboard everyone. Do you know the actual reason why the marathon session is conducted? What's the reason behind it? So by the way, all those students who are new to this session and who are new to this channel, this is Shreyas and I have been teaching for a very long time, producing amazing, awesome results. Some of my ranks have been, like 2-digit ranks, within 20, within 30, within 40, all India ranks in JEE Mains, JEE Advanced. I hope you will do the same. And guys, if you want to get in touch with me, you can do so. Feel free to contact me on Shreyas_Vedantu. That's my Instagram handle as well. Hello Gaurav, hello Anusha, hello Mukt, hello Hoin, hello Ankit, hello Gaurav Kaushik, hello everyone, hello everyone. So guys, the thing is, yes Ankit, you can attend even if you are in 11th. So guys, the real reason why we conduct marathon sessions is because understand your final examination is no less than a marathon. A lot of people give you a lot of strategies. Even I have given you so many strategies. But let me tell you one very important strategy today. In fact, I have done, or rather, in this day, you would be implementing both these strategies, which will help you ace the JEE Mains as well as the JEE Advanced examination. So what are these two very important strategies? Listen to me very carefully. Two very important strategies. What are those two important strategies? The two important strategies are: number one, you should be comfortable and you should have that habit of studying for at least 3 hours without even getting up from your seat, at least 3 to 4 times a week. Yes, if you are in 12th standard, at least 3 to 4 times a week, you should be able to sit continuously for 3 hours. Yes, you can drink water, but not even go into the toilet, guys, because your final examination is going to be that way. Remember that. Because if you try to divert your attention or if you take a break in between, that means your brain is used to that. So in the examination also, your brain is going to think for alternatives and you are going to get deviated and your concentration will decrease and you will make mistakes and sometimes even silly mistakes. So that's what is going to happen. So understand, it's very important to study at a long stretch. At least make it a habit. If you are in 11th or 10th standard, at least start once a week, then make it twice a week, and by the time you reach 12th standard, it should be 3 to 4 times a week. That's number one. Number two, you should wake up early. A lot of people tell you can sleep anytime and you can wake up anytime, but yes, remember, you should at least wake up by 7:30, guys. The reason is because your final examinations are going to be in the morning. Some of the morning slots are there. BITS examination and CAT and boards and so many, even advanced examination is throughout the day. So your mind should be active right from the morning till the evening. So guys, this is your study time. Do not utilize it for sleeping in any way. Do not take afternoon naps. That's very important. So two very important tips that I have given over here. Very important, that will help you ace the preparation. Hello Daimi, hello Sneha, hello Veer, hello everyone, hello everyone. So power naps also not recommended even in the afternoon. It's not recommended because if you take power naps, then what will happen? Your brain will be habituated to that. So your brain will think, oh, I need sleep, oh, I need sleep. But actually your second paper of JEE Advanced will be going on, or your second shift might be going on in JEE Mains. So that's why I'm saying do not do that. Hello Kakani, hello Harshavardhini. Yes, you came in the morning. Glad to see you back again over here. Let's then go ahead and let me tell you, all the new timers out here, do not forget to hit the subscribe button, because only then you will be getting all the updates. And if you're already subscribed, you know what to do. Smash that like button out there, because only then I'm going to get the energy. Guys, today's session is a marathon session. It's going to be more than 2 hours, or maybe at least 2 hours. I'm guessing so. So today we're going to talk about magnetism. Tomorrow morning, 8 o'clock, we're going to meet again for KVPY, and then you can celebrate Christmas, and Saturday again a marathon on magnetism. Alright, so that's the schedule for the remaining part of the week. If you have missed any of these classes, you can definitely go ahead, check it out in the playlist or in the past videos. So today we conducted a Menti, on capacitors. Chemistry Menti will be on Sunday, 9 o'clock. So keep that in mind as well. Tuesday you had the maths Menti. In case you have missed it, you can check any of these Mentis out. So let's begin, guys. Let's get ready. I hope you guys are ready with all your pakodas, sandwiches, chips, biscuits, juices, whatever you want to have, because it's going to be a long session. Come on, guys, get ready, and I hope you have already smashed that like button. Okay, very good, Jimna, very good, Kirto, very good. Yes, it is in KVPY too, very good. Yes, first marathon session on the Enthuse channel by me. Yes, let's begin. Hello, Shreya. Okay, so first let's talk about magnetic field, guys. Keep making notes. That's very important. All the chapters topic will be completed in today's session. So just like you have electric field, similarly magnetic field can be visualized by keeping a compass around a magnet, and the compass will point in particular direction. If you move the compass around that magnet, wherever it points, that gives you the direction of magnetic field produced by the magnet. So you can measure how the magnetic field flows by taking a small magnetic needle and see where the needle points. If the needle points there, take the magnetic compass in that direction. Now see where there is a needle point. If it points there, then take the magnetic needle over there. So if you trace that curve, that is the line of magnetic field. It tells you how strong that magnet has been produced. Either it could be a permanent magnet, or it could be an electromagnet, or a horseshoe magnet, doesn't matter. It tells you the strength, the direction of that field. Only when you know the field of a magnet can you find out the force and how does it affect other things. So let's see how many of you can get this question. Which of the following is not the correct representation of magnetic field? More than one may be correct. Understand? Let's see how many of you get it. Okay, very good. Sayukta has already eaten. Glad to see you back, Ankit. All right. Guys, understand, more than one may be correct. Understand? More than one may be correct. Which of the following is not the correct representation of the magnetic field? Come on, think about it. A lot of you are saying B. Some of you said C, D. Some of you said B and D. Okay. So let me tell you guys what the correct answer is. Are you guys ready to see the correct answer? You might be shocked. By the way, the correct answers are A, B and D. All these three answers are not possible. Please read the question carefully. Which of the following is not correct representation? Not correct. Very important. It's not correct. Understand, magnetic field lines cannot intersect. Here they are intersecting. So this is not possible. This is also true for, by the way, electric field. No field lines can ever intersect at any point, so this is not possible. Next, you might be like, sir, what is wrong over here? The thing which is wrong over here in these two things is that magnetic field lines can never originate and can never terminate. They are always continuous. Yes, they are always continuous. They never start and they never end. That's one big difference between electric field and magnetic field. Electric field, this is possible. In fact, in a capacitor if you have two charge plates, this is how the electric field lines look like. This is the electric field lines for a dipole. But for magnetic field, it won't look like this, guys. They can never start and they can never end. Remember that. So how do magnetic field lines exactly then look like? You might be thinking, sir, but I was thinking that magnetic field lines originate from the North Pole and they end at the South Pole. Well, partially you are correct, but do not forget, even inside the bar magnet, the magnetic field lines continue. Yes, they will continue like this. So that's why they actually never stop. they continuously flow, understand, in closed loops. Very, very important. Yes, it's a closed loop. Very good, very good. Yes, Ankit, you can make notes. Definitely, definitely. I think Sayukta already answered your question. Very good. So, now that we are talking about magnetic field, let me give you some more pointers. First pointer is they are always closed loops. That means they never terminate, alright, or originate like electric field lines. Next, the strength of the field, alright, is directly proportional to the density, or basically the closeness, how closely they are packed. Like you can see over here, they are very closely packed. The density is very large, so the field is going to be very strong over here. But if you see, the spacing is very wide here, so the field is going to be very weak over here, just like in the case of electric field. Lastly, understand they cannot intersect, that is common, and the unit of magnetic field, alright, is Tesla. Everybody knows Tesla because of Tesla cars and so many other things, but Tesla is the unit. But understand, Tesla was a very, 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 very famous scientist, but actually became famous after his death than you know, when he was living. There are many interesting stories about Tesla. Maybe I'll talk about it some other time. And the unit, the symbol is B. So B is the symbol for magnetic field, just like E is the symbol for electric field. So Tesla. Some other units are Gauss and other things, but generally we stick with Tesla because that's the SI unit. Okay, I hope this is clear. Yeah, there are a lot of stories between Thomas Edison and Tesla, how their fights were and all that. I'll talk about it some other day. Okay, I hope you have made notes about that. Now, how does the field affect the charges? How does this magnetic field affect charges? Now we're thinking, sir, what about field affecting magnets? Yes, we'll be talking about it in some other part, not today. Today's topic is completely about how does magnetic field affect charges. Now you might be thinking, sir, but we thought that electric field only can affect charges, and we have seen how electric field affects a charge placed in its vicinity, and the formula for that is F is equal to QE. Q is the charge, E is the electric field, F is the force because of that field. But can magnetic field also, affect and charge? That's what we are going to see. I hope you understand what I plan to do today. So how can magnetic field affect charges in different ways? So many different problems, mains level, advanced level, KVPY level, every type of problem will be solved today. But before that, let me tell you, all the 11th standard and the 12th standard students who are still not, probably not made up their mind, please make up your mind for the pro subscription course as well. Guys, this pro subscription course not only has a long-term batch, but it has so many other things which you get in your regular coaching as well, like test series, assignments after every class, and you also get the booklet which is called Tattva booklet, which Vedantu gives. This is your coaching booklet, and it has all the formulas, problems right from level 1, level 2, etc., solve examples, important stuff. Then after every test you get detailed assessment of each test as a report card, where you went wrong, how many mistakes, where are you spending more time, because all the tests are online, remember that? So the analysis becomes very easy for the computer to do. So a lot of artificial intelligence behind and machine learning behind all these tests, which gives you very nice detailed report cards. Plus you get 2 teacher models. So in the class, apart from the main master teacher, you have the class teacher who will be assisting you with the doubts during the class, and even after the class you get the doubt app where you can ask all the doubts that you would love to ask. So all the doubts you guys have can be asked in the Vedantu doubt app itself, and there are additional courses which you can take if you feel that you are weak and in some particular topic. Say for example SHM, you do not know much about SHM, you can just take a micro course on SHM. If you want to prepare for KVPY, there is a course for KVPY. Physics numerical course, HC Verma course, all kinds of small courses are also available which will help you boost your performance. So guys, it's a complete package. Even board preparation is taken care of in this course. So it's a one-stop solution, understand. You don't have to run behind 100 different things. At one place you get test series, coaching, material, you get assignments, you get all the best teachers, everything at one place. And the price is not at all high if you compare it with the regular coaching fees. I'm pretty sure you know how much it is. So for 6 months, it is actually 39,000. You can check now, you can compare, but because you're going to get an offer, this price will come down to just 27,000 guys. So it's hardly 150 rupees per day. So go check it out, check out all the prices, check out the different subscription models. The link is there in the description box below, and use this coupon code SHHPRO, and when you use this coupon code, you will be getting the 50% off and whatever offers are running. So this is the highest discount coupon code that you can ever get. And just check it out. Check out all the detailed information. It's in the description link. Plus, it's already been shared on the chat as well. All right, let's get going. Yes, Ankit, I'm taking almost every day a week. So I'm taking classes every day a week. Yes. So Science Priya, I will be doing something special for Christmas for sure. Chalo, let's see what I can do. But definitely I can't dress up like Santa Claus. Alright, I'm not that fat, at least now. Okay, so let's get going. Let's get going. VK channel, I'm very good. Yes, Princey, I know, I wished. Already I have wished, Vani ma'am. Alright. Chalo. So guys, force on a stationary charge in magnetic field. If you take a charge and place it inside the magnetic field, and if you think that there will be a force, no, there will be no force on it. So a stationary charge at rest inside a magnetic field, there will be no force acting on it. Very important. But remember, if there was electric field, that electric field will exert a force. Electric field will apply a force QE, but magnetic field will not apply a force. This is what is experimentally found. Now, next case or scenario. If the charge is moving parallel or anti-parallel to the direction of the magnetic field. So you take a charge like a proton or an electron, throw it in the direction of magnetic field. Then also you will see that the force acting on that charge is zero. Yes, the force acting is zero. So you might be wondering, what the hell is this? I mean, I throw the charge, I keep the charge, there is no force acting on it. So when does force exactly come? So understand, whether it is thrown here or whether it is thrown here does not matter. The force is zero. Very, very important. I hope you guys are understanding. Ankit, if you see my first slide of KVPY, I mentioned it very clearly. Does KVPY help JEE? Yes. Does JEE help KVPY? Yes. So in a way, it's a JEE session only. Think about it. Okay? Because it's not different. See, if you study Newton's laws, it's not like you are studying Newton's laws for KVPY or for JEE. Newton's laws will remain Newton's laws. So a lot of people fool you around saying, oh, this is a special Newton's law class for KVPY. It's just that you solve KVPY related questions. That's it. That's the only difference. Understand? Okay? So we are doing JEE related stuff only every day. Hold on. Alright. So next situation. When it is perpendicular, then what happens? Then the force comes. Yes. When it is perpendicular, it is found that the force comes. And if you throw it here, and if the magnetic field is there, V cross B. If you point your fingers of your right hand first in the direction of velocity and then in the direction of magnetic field, whatever the direction of the thumb, that's the direction of the force. So it will be inwards, so I'll show it a cross. So that's the direction of the force on which is applied on that charged particle, provided it is positive. This will be the force on a positive particle, and if it was negative, it is exactly opposite. I will show it like a dot. Dot vector means it is coming towards you. So what you need to do to find the direction of the force, first point your four fingers of your right hand in the direction of velocity, bend it towards magnetic field. automatically the thumb will point in a particular direction. That is the direction of the force acting on the particle. But that is positive. If it is negative, it will be exactly opposite to your thumb's direction. Okay, so it is not definitely in the plane, it's going inside the plane. This one is coming outside the plane. Very, very important stuff. Now, what is the magnitude of this force? So let's talk about the magnitude of this force. So guys, the answer for this is the force is given by Q V cross B. This is a cross product, so you should remember this formula. And magnitude wise, it is Q V B sine theta. What is theta? Theta is the angle between velocity and magnetic field. So that's the angle between velocity and magnetic field. So if you throw any particle in magnetic field, the force experienced will be Q V cross B. Now think about it. If velocity and magnetic field are in the same direction, their cross product will be 0 because theta will be 0. So that's why there was no force. Second thing, if velocity is 0, that means it is at rest. Then also the force is 0. Magnetic field is 0, then also force is 0. Charge is not there, like a neutron, then also the force is 0. So only when you throw it in any other direction apart from the magnetic field, only then a force is experienced. That's what should be there in your mind. Second important thing, if this Q is negative, automatically a minus sign will come. Automatically a minus sign will come. That means whatever answer you get using V cross B, using a right hand rule, the answer is exactly opposite in direction. So that's why on a negative charge, the force will be exactly opposite to your right hand thumb rule. So just find it using your right hand thumb rule and just invert it. That's the answer for a negative charge. Alright, I hope this is clear. Now, when will the force be highest? Yes, we'll come to that in a bit. I'll show you a very simple simulation, but this is some formula which you should remember now. Now, always you should be able to figure out which direction the force is no matter where the velocity is. Try this out. The velocity is coming out of the plane of the board, guys. The velocity is coming out of the plane of the board. Magnetic field, if it is here, try it out. Put your thumb like this. It's difficult. Try to do it. V cross B. The forefinger should be pointing towards you and then it should bend like this. Please don't twist your hand too much. Don't break it, or else you'll blame me. So velocity will be here and magnetic field is on the top. You will see the force coming that side. All right. I hope you get it. So all my notes are there in the description box below and even in the Telegram group. So not exactly my notes, but it's in the printed form, not my handwritten form. Okay, so all the extracts, everything are there. Okay, I hope this is clear. I hope this is clear. Got it? Very good, very good. I hope everybody was able to twist their hands and do it. Come on. Okay. Now, it's very important to know that the angle decides the force. If the angle is 90, then the force is maximum because sine 90 is 1. If the angle theta is 0, then the force is also 0. So as you can see, as the angle between velocity and B reduces, the force also reduces and it becomes 0 when they are either parallel or even anti-parallel. Both ways it works. Alright, so I hope you guys are getting this. Very, very interesting stuff. Let's start solving some problems now. So here is the first question on your screen. A proton enters a magnetic field of value 1.5 Tesla. Forget the word flux density. Flux density is a synonym for magnetic field. Okay, so you'll learn about it later on, but for now just understand it is magnetic field with a speed of this much, 20 into 10 to the power 7 at an angle of 30 with the field. The force on the proton is how much? Come on, the options are on your screen. The options are on the screen. So Sayukta, which part you didn't understand? Can you please tell me? Okay, VK channel, very good. You are in 10th standard and you are understanding everything. Very good, very good. Keep it up. Glad. Come on, guys. Think about it. Think about it. What should be the answer? What should be the answer? What will you do? Use the formula. Use the formula. Come on, use the formula and see what you are getting. What are you getting using the formula? Come on, try it out, try it out. Come on, guys. VK channel says B. What about others? What about others? Fida also says B. Acha. Okay. And others? Come on, come on, come on, come on, everyone. It should not be so difficult. It's coming B. Very good, Princey. Acha. Ali, I'm very good. Join in, Ali. Long time. All right. So the correct answer is actually B, guys. Very good. Very good. Very good. Very good. So how do you do it? Force is Q V B sine theta. Just use the formula. Q is how much? Proton's charge. What is the charge of a proton? Same as the charge on an electron. So 1.6 into 10 to the power minus 19 into velocity. What is the velocity? It's given 20 into 10 to the power 7 into magnetic field. How much is it? 1.5 into sine theta. Theta angle is 30 degrees with the field. So it is basically sine 30, which is nothing but half. That's it. Do this and you should get it as 2.4 into 10 to the power minus 11 Newton. Correct? So now, Ali, post in the comments or contact me on Instagram. I'll help you. Okay? Now, you might be thinking, sir, the force is so less. Why are we even studying this chapter? If the force is so less, it will not even cause any problem. Yes, the force is very less. But now think about it. What will be the acceleration because of this force? Remember, force is equal to mass into acceleration. So acceleration will be the force, which is 2.4 into 10 to the power minus 11 upon the mass of a proton. Now the mass of the proton is approximately 10 to the power minus 27 kg. Approximately the order will be 10 to the power 27 minus 10 to the power 11. So it will be approximately of the order of 10 to the power, guys, 16. Can you see that? Can you see that, guys? I hope you saw that. Now that is a huge acceleration. That is why we study it. That is why we study it. Yes, because the mass of these particles are very small. The force might be small, but the mass is even smaller. What an incredible answer this is. All right, let's get going. Let's get going. Okay, now let's talk about, a charged particle thrown in a magnetic field. We saw that the force is always perpendicular. All right, the force is always perpendicular to the velocity as well as the field. Now just think about it. If I throw a charge in the magnetic field such that, just imagine velocity and magnetic field are perpendicular, then since the force is always perpendicular to the velocity, think what will happen. Think what will happen. It will go in a path like this. Look at this. This charge is thrown with a velocity this way towards minus x. Magnetic field is coming towards you. You can do this. V cross B. V is there. B is towards you. V cross B. Come on, move your fingers like this. Thumb will point upwards. Check it out. Thumb will point upwards. So force is here. So that's why the particle's velocity is gradually changing like this, direction wise, but magnitude is not changing. Does this remind you of something? Obviously, circular motion, and that too uniform circular motion. In fact, if this magnetic field was there everywhere, this particle will continue to go in a circular path, and this force will be the centripetal force. Remember, there is no force along the tangent, and because there is no force along the tangent, there is no change in the speed or the change in the magnitude of the velocity. Only the direction keeps changing. So this perpendicular force can only change the direction. Understand? So a perpendicular force like this force can only change direction. This force acts like centripetal force. And lastly, I can say that it can't change the speed of the particle. And lastly, I can also say doesn't do work. it doesn't do work. Remember, for work, if the force is perpendicular to displacement, work done is 0. So here always the force is perpendicular to the displacement, so magnetic field's force can never do work. Remember that. We'll be coming to that, Ali, in a bit, okay, towards the end of the lecture. So very important, magnetic field's force never does work. Okay, now based on this concept, imagine I throw a charge. Again, use your right hand. Imagine the velocity is there, magnetic field is inside because I've shown by a cross. So V is there, B is inside, force will be here, up like this. This force will continuously change the direction of the velocity and the particle will perform a uniform circular motion. Now we can find everything about it, like the radius, etc. Think about it, that magnetic field force will be m into centripetal acceleration. The force due to the magnetic field will be mass into centripetal acceleration. What is this force? It is charge into V into B into sine 90. Why is it sine 90? Because the angle between velocity and magnetic field is 90 degrees, guys. Velocity is there, magnetic field is inside. Velocity is there, magnetic field is inside. So the angle is again 90 degrees. So understand, that's why it is sine 90, guys, is equal to mass into, understand? Sorry. Okay, so mass into centripetal acceleration, which,
please try again.
oh, so sorry guys, that was my phone, Siri getting activated for no reason. Alright, so AC will be nothing but V square by R. Now think about it, 1V will go and you will be just having QB is equal to MV by R. Therefore, R will be equal to MV by QB. Now this is a formula which you should remember, memorize this formula. R is equal to MV by QB. Very important. Very important. Yes, magnetic force can never do work. Very good, guys. Very good. Yes, guys, have some patience. Everything will be taught to you. What is this session? This is a marathon session. Everything will be taught to you. Yes. Next important thing in this. The next important derivation in this, guys. Understand, I can also find the time period. Yes, how can I find the time period? Just remember, time period will be how much time is distance by speed. The distance is circumference, alright, divided by how much speed it travels with, because it's uniform circular motion. So the circumference is 2 pi r, correct, and the speed is v, alright. But I can substitute the value of r over there. So let's see, what do I get? I'll get 2 pi, I just put it here. So I'll get 2 pi by v. R's value is mv by qb. mv by qb. Best part, v gets cancelled and I will get time period as 2 pi m by qb. Now should I tell you a very interesting thing? See guys, it's independent of velocity. Yes, does not depend on velocity. That means even if you throw the particle really fast, it will still take the same time to complete one circular motion. Yes, if you throw it slow, then also it takes the same time to complete one circular motion. But what will be different will be the radius. Obviously, if you throw it really fast, the radius will be very large. If you throw it slowly, then the radius will be very small. But the time periods will be same. Alright. Suji, koncham blur undi. Please try to increase your, what do you say, that resolution. It must be in 360p. Make it to, 720p or 480p at least. Alright. Let's get going ahead and let's see if you can solve this question. A proton and an electron are projected towards the right side or towards any side with the same momentum in a uniform field. Okay, which one will have more radius? Which one will have more time period? Which one will have more radius? Which one will have more time period? Alright. So guys, let's see how to solve this question. Proton and electron both are projected with the same momentum. Very important, same momentum. Now what is the radius formula? Radius formula is mv by qb. Now what is mv? It's momentum. So it will be p by qb. Now think about it. For an electron and for a proton, since this quantity P is given to be same, even magnetic field is obviously the same, they are in the same magnetic field. The only thing that is different is Q. Now, is it different actually? Think about it. Yes, sign wise it is different, but magnitude wise it is not different. So proton and electron both projected with the same momentum, the magnitude of Q is same. So the magnitude of the radius will be same, but understand their signs are opposite. That means what? If one will go this way, the other will go that way, just like it is shown over here. Just like it is shown over here, their radiuses will be same, but both will come meet here and something like that. Okay, but I hope you understand the radius will be different. Oh, radius will be same, but the directions will be different. All right. Now, let's think about the time period. Which one will have more time period or less time period? What was the formula for time period? The formula for time period was 2 pi m by qb. The best part, it is independent of velocity. Radius will be the same, but will the time period be the same? Think about it. Think about it carefully, guys. Q and B are same magnitude wise. Magnitude wise, you know, they are the same. 2 pi is a constant, but is m same? Obviously not. For proton, the mass is more. Mass of proton is more than mass of the electron. So who will have more time period? Who will have more time period? Obviously, time period of proton is more than time period of electron. That's it. So both will have the same radius, but proton, understand, will take a longer time. Electron will come quickly. So electron will be moving fast and proton will be moving slowly. That's how amazing this will look like. Just visualize this, guys. It is so fascinating just to visualize this. Very good. Understood? Such kind of problems do come in JEE Mains, KVPY and other examinations, guys. Very important. Alright, let's go to the next question. This is a beautiful question. Beautiful question. This is a JEE Advanced type of question or KVPY type of question. Let's do this. Come on, guys. Show some Josh and also hit the like button out there. Come on. I'm going to be there with you for a very long time today. Okay. So an electron of mass m enters a B field of width. This width is L. As shown, find the minimum width such that it returns back to the original region 1. This is region 1, this is region 2, let's say that's region 3. If the width is larger than the width which you have found, how much time does it spend inside the field? Now it looks like a complicated question, but believe me, yes, Nandini, I take all the long-term batches, yes, and a lot of micro courses, yes. I'm just not teaching on YouTube, I take the regular batches on Vedantu as well. So it looks like a difficult problem. This came in JEE Advanced. Now how to solve this? Just think about it. Electron is thrown that way, magnetic field is this way, velocity is there, magnetic field is here, use your right hand, V there, B here, V cross B here. It's upwards. But hold on, that's an electron. Oh, it's a negative charge. So I need to flip my thumb, it will be like this. So the force is going to be here, the force is going to be down. So once it enters here, it's going to start turning, but it will not complete the complete circular motion. Why won't it complete? Because it can only stay inside the field till here. After it comes here, the field is over, so it will come back. So it will look something like this. Look at this animation. This will give you a very good visualization. Guys, today's lecture, I'm going to make you visualize everything. A lot of people say, sir, magnetism I can't visualize, sir, electrostatics I can't visualize. I'm going to make you visualize everything, guys. After this lecture, you will never face difficulty in magnetism. Okay, so this is how the path will look like. I hope you can see that. Now, what is the question, guys? The question says, what is the minimum width such that it returns back to the region? Guys, if imagine the magnetic field is so much, obviously it will return. If the magnetic field is this much, then also it will return. But if the magnetic field is only so much, if it is only so much, do you think it will return? Obviously no. What will happen? After this, it will just come out. It will just come out. I hope you can visualize that. So guys, I hope you can see this. If the magnetic field is somewhere less than this point, this particle is just going to come out here. It's going to come out in a straight line because this side will not have magnetic field. So that means how much should be the minimum distance of that field? How much should be the minimum distance of the field? It should be equal to the radius. And what is the radius, guys? It is mv by qb. So that's the answer for the first question. The minimum width will be mv by qb. Very good, very good, very good. Now, the question is, how much time does it spend inside the field, assuming the width is larger than that radius? How much time does it spend? Can you give me the answer? Can you give me the answer in the chat box now orally? How much time does it spend? Is it spending one complete time period? No, right? It's spending only half the time. So what was your original formula? It was 2 pi m by qb. This was the times formula. But now it will spend only half the time. So divide by 2. So the answer will be pi m by qb. I hope this is clear. Yes, very good. Half the time. That's it. This came in JEE Advanced, guys. Yeah, these kind of questions came in JEE Advanced. Can you believe that? People were not able to visualize only what was happening. Okay, anyways. Chalo, let's get going to the next question. Now, alright. Let's take another scenario. Let's take another scenario where, see, we have seen what happens when a charge is stationary, when it is perpendicular, when it is parallel. What if the charge is thrown at an angle with the magnetic field? It's going to be very interesting stuff. So let's see what happens. Now, to do that, just think about it. This velocity can be split into two components, v parallel and v perpendicular. Guys, try to recollect. If only v parallel was there, that means if the charge was going parallel to the magnetic field, will there be any force because of this parallel velocity? Is there any force because of the parallel velocity? Didn't I tell you this? Is there any force? Yes or no? Come on. No, there will be no force. Very good. No force. Zero force. Correct. So who is responsible then for the force? Only the perpendicular component. Now, I will just forget these two things. Just imagine perpendicular velocity. Magnetic field is there. Come on, everybody use your right hand. Please don't drop your phone if you're holding it in your right hand. So velocity is there. Magnetic field is here. V cross B, guys. Come on, V cross B. Where is it coming? It's coming there, guys. It's coming there. That side, inside the board. So you know what is going to happen? Because of this velocity, that particle is going to go like this. It's going to go like this. It's going to go like this in a circular motion. I hope you can visualize that. The V is there, B is there, V cross B is here, force is here. So that velocity will keep turning like this. So it's going to go like that. But do not forget, there is also one more velocity which is in this direction. So this motion will be there along with this motion, forward motion. So just think about it. It's not only going in a circular path, but also going forward with V parallel velocity. What does it look like? 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 Doesn't it look like a spring-like motion, guys? Doesn't it look like a spring-like motion like this? Think about it. It will go in this path. This spring-like motion is called as helical path. Very good. Yes, like a screw. Yes, so this will look like a screw, or it is called a helix or a helical path. So very important. Now, let me give you some important things about this helix. So, very important questions can come. Note it down, guys. This distance from one coil to the other, this is called as the pitch of the helix. Remember, this word pitch also came yesterday in micrometer screw gauge. When you rotate it once, how much do you move ahead by? Same thing. When you go around once, how much do you move ahead by is called as the pitch. And in this situation, remember, the circular motion, alright, the circular motion is because of the perpendicular velocity, and the forward motion is because of the parallel velocity component. So now, here is the trick, guys. If this was my velocity, this was my angle, this was V parallel, this is V perpendicular. How much will be V perpendicular? It will be V sine theta. How much will be V parallel? V cos theta. Now, if I ask you, what is the radius of the helix? So where is the radius? So you have to see it from here or see it from there. You will see the radius of the helix, guys. This will be the radius of the helix. Okay, so this is the radius of the helix. You can see it when from here, guys. You have to visualize this. You will see that circle over there. So guys, can you think what will be the radius of the helix? Guys, it's just the radius of that circular motion. Only V perpendicular will be responsible. V parallel will not be responsible. So just look at V perpendicular. It will be M V perpendicular mv by qb. That means it will be mv sine theta by qb. I hope this is clear. So that's the radius. Very good, very good. Now just think about it. What will be the pitch? The pitch will be, in one rotation, how much do you move ahead? In one rotation, how much do you move ahead? So it will be V parallel multiplied by time period. Because in that direction, you are moving with parallel velocity. So velocity into time gives me distance. So that's the pitch. In one rotation, how much do I move ahead? So how much is V parallel? That's V cos theta. And what's the time period? It's independent of velocity, guys. Come on, 2 pi m by qb. That's it. That's the pitch of the helix. So these kind of questions do come in the examination. Very good. Not complete velocity, only parallel velocity. People forget to take the parallel component. Okay? I hope this is clear. Excellent, guys. Excellent. Very good. Very good. Keep the josh high. And guys, remember, I will only know that you are here only when you keep chatting and keep getting involved in the discussion. Keep chatting with each other as well. Keep the josh high, because only then you will interact. You will know all the other people out here. You will make new friends. Yes. Okay. Very good, Amir. Very good. Very good. Very good. Okay. So now let's get going to the next part of this. Very good question coming up on this concept as well. Hold on. So by the way, this is how the motion looks like. So I just wanted to show you a simulation. Just look at this. This is how the helix looks like. Look at the magnetic field. It is there. And look at the charge. It was thrown at a small angle. It goes like that. What a beautiful motion, guys. What a beautiful motion. Guys, show some love. Yeah, I do so much for you. I wake up early in the morning. I have taken so many classes. I have done so many shoots today. I have shot for some very special things. And still I'm going to stand for you. I'm going to be there till the end. Till you write your final examination, till your counseling, till everything. Don't worry, I'm going to be there and helping you out. So show some support and never miss a class. All right. Let's see the amazing question in front of the screen now. If you throw a charged particle from a gun, lot of charged particles, look at this. This gun is shooting so many particles. And the magnetic field is here. But they are thrown at small angles with the direction of magnetic field. As shown, what is the first focus point of the particles? Look at that. They are focusing somewhere. You can see that? Can you see that? They are focusing somewhere. Very good question. This again came in a very different way in JEE Advanced. I've changed, altered that question. What a question this is. So, it will also deflect. It will also deflect. Alright, just like any other charged particle, it will also deflect. Use the formula QV cross B, you will find the direction and you can also find the magnitude. Now, how do we find? You'll be like, what the hell? Is this a question on optics? Should I use some focal length formula? No. Just try to understand what is happening. Guys, when you throw these particles at an angle, how do you think the motion of the particles will be? How do you think the motion of the particles will be? Will it be circular, straight line, helix or something else? Parabola? What kind of motion it will be? Thank you, Princey. What kind of motion this will be? Will this be circular, parabola, helical, straight line? What kind of motion this will be, guys? Think about it, because no, it will not be straight. Think again. They are thrown at an angle, guys. Look at the question. They are ejected from the gun at a very small angle. So when the angle is there will be two components of velocity. One in the direction of field, one perpendicular to the direction of the field. So guys, what happens when the angle between velocity and magnetic field is there? It will go in a helical path. Yes, they will all go in a helical path. So each particle is going like this. Imagine guys, just simulate this in your mind. ऐसे ऐसे करके जा रहे हैं. They are going like this, zig 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 करके, and they are meeting over here. They are meeting. All these particles are meeting over here like this. What a fascinating thing it will be. So where are they meeting is the question. Now to solve this, it's very simple. I'll tell you what to do. Imagine guys, this is your gun, okay, and you're shooting particles at a very small angle. This is V, and with the axis, that angle is very small, theta is small, and your magnetic field is in obviously this direction. Now think about it. These particles are going to go something like this, helical path, okay, and just imagine guys, they are projected on this line. This is my x-axis. They are projected at this angle. They will go like this, okay, they will go like this, come like that, and come back on this line exactly after one time period. Can you visualize this? Imagine this to be the straight line magnetic field. They are thrown at an angle. They will go like this and come back on the same straight line exactly after one time period. I hope you are able to visualize this. This will be when it's exactly one time period, and they will come exactly on this same line over here. Now think about it. Their parallel velocity to the field, which is V cos theta, will be approximately V. Reason? This cos theta is approximately 1. Remember, cos of 0 is how much? 1. Cos of 1 degree, 1. Cos of 2 degree, almost 1. So all of them have the same velocity almost in this direction. All particles, no matter what small angle it is, 1 degree, also 2 degree, 3 degree, almost same speed in this direction. And what about the time period? Remember, time period was always independent of the speed, guys. Time period was always independent. So time period was 2 pi m by qb. Now think about it. How much distance will they travel from here to here? Exactly will be the pitch. From here to here, when they come back on that same line, will be the pitch, and that pitch will also be the focus. Think about it, because all the particles will go like that and come back on the same line. Each particle will go probably in different circles, small difference, but they will again come back on the same line almost at the same point. So now, what will be the answer, guys? So the focal length will be the pitch, and what is the pitch? It will be V into T. So it will be nothing but 2 pi m V by QB. That is the answer. That is the answer. Mamta, not now, maybe later on. The applications will open later on. I hope this is clear. Don't spam, Mamta. Mamta, don't spam. Don't spam. Don't spam over here, or else the channel manager will block you. Don't spam, okay? And if you have some doubts which are apart from the syllabus, please post it in the comment section. I'll respond it, or you can contact me on Vedantu, Shreyas_Vedantu. That's my Instagram handle. Contact me over there. I'll definitely help you out. Okay. So that's the answer, guys. I hope this is clear. Yes, 2 pi m. Wow, nice way of putting pi symbol. Love it. And I'm also hungry. Okay. So now let's get going. Let's get going to the next question, guys. So let's also take a break meanwhile, and I'm planning to have some little hearts because I'm also feeling little bit of hungry. So if you want to grab a sandwich or something, please do that. My favorite biscuit is Little Hearts. What is your favorite, guys? And this pie especially made me hungry. Yeah, I'm feeling little bit hungry. How many of you like Little Hearts? Don't worry, Rahul. With me, these dreaded chapters will become very easy. Acha, pizza. Okay. Lot of you are liking little arts. Very good. Princey has posted lot of food items. Wow, 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 wow. Science Priya wants it. Selva also wants it. Jumna also likes it. Sneha too likes everything. Suji likes Suji pakodas. No, Suji likes little arts too. Krito likes jade parcels. Interesting. Thank you, Rahul, so much. Why am I doing like this, Saurav? Come on, go grab a biscuit or something like that. Come on, go ahead. All right, guys. So let's get going. This break was necessary, I guess, because it's a marathon session. Yeah, I will not forget the pizza party. Wow, you're eating a Helix. I like those Bikaner wala ka mixes and Haldiram mixes. Kuch kuch or something. There is some kuch mix or something like that from Haldiram. It's very nice. All right. I hope you guys are all energized now. Shall we go ahead? Samosa and chai in winters. Wow, yaar, Dayami. Don't remind me of that. I love drinking tea. It's so nice. And that too with samosas or pakodas. So nice it is, especially in cold winters. Too good. Okay, let's begin. Spammer, bhai, spam mat karo. Don't prove your name. All right, let's get going. Kachoris are also very nice. I love kachoris. And Bangalore, you get very few places you get good kachoris and samosas and pav bhajis. Okay, so let's get going, guys. On your screen, next question coming up. Come on, guys, start solving. In a region, steady and uniform electric and magnetic fields both are present. Yes, both are present. These two fields are parallel to each other. A charged particle is released from rest in this region. The path taken by the particle will be. Come on, think. What should be the path taken by the particle, guys? Okay. Lot of various answers out here. B, D, A, B, D, B again. All right, come on. What do you guys think? C as well. All right. Wow, Srikanto, then give the answer then. Or did you get it there? Acha, chalo, let's see. The correct answer is a straight line, by the way. You might be wondering, why the hell is it a straight line? Guys, read it carefully. In a region where electric and magnetic fields are present, they are parallel to each other, first of all. Okay, let's draw it first. So, the electric field and the magnetic field are parallel to each other, and a particle is released. Very important. So if you release a particle, that means initial velocity will be 0, but do not forget there will be a force only due to electric field initially. So that force will push it here. That force is because of electric field. Now as soon as that particle gains some velocity here, think about it, this velocity will not be affected by B because V cross B is 0. So the force due to magnetic field will always be 0. So it's just a simple question where a charged particle just gets accelerated only because of the electric field. Magnetic field has no effect on it. So hence it goes in a straight line without anything. So that's the answer, guys. I hope this is clear. Magnetic field is not 0, force due to magnetic field is 0. Alrighty, let's get going. Yes, Mehak, ISC, ICSE, CBSE, State Board, all this syllabus will be covered here. That's why it's useful. It's a very special channel because we cover all the competitive exams out here for engineering, and plus it is helpful if you are preparing for any other boards and any other exams like NEET as well. Alright, and even for NTSC and other Olympiads. Now, let's talk about something called as the cross field. Now, what is a cross field? Cross field means, cross means what? Perpendicular. If you have velocity perpendicular to magnetic field and magnetic field perpendicular to electric field, that is called as crossed field. So all three, electric, magnetic and velocity, are perpendicular to each other. That is the meaning of cross field. These kind of questions are very common. Let's do this. So guys, magnetic field is inside, electric field is here, velocity is there. This is a very special scenario. You will be wondering, why is this so special? I'll tell you. Think about it. Because of electric field on this charge, what will be the direction of the force? Field is here, force will also be down. So the force due to electric field will be downwards. Correct? Now think, what will be the direction of force due to magnetic field? Use cross product rule. V is there, B is inside, V cross B. Where does your right hand thumb go? It goes up. Wow, that's interesting. It goes up. Now, if by chance these two forces are equal, what will happen? If by chance these two forces are equal, net force will be 0. And if net force is 0, the velocity will not change. So the particle will go in a straight line in spite of electric and magnetic fields in weird directions. And what will be the reason? What will be the condition for that? For no deflection. Alright, for no deflection, understand the force due to electric field must be force due to magnetic field, and force due to electric field will be QE, and force due to magnetic field will be QVB sine 90. Why sine 90? Check the angle between velocity and magnetic field. Velocity is there, magnetic field is here, the angle is clearly 90 degrees. You can see that. So QQ cancels out, that's the best thing, and speed should be E by B. Very important formula, remember this. If the speed is exactly the ratio of electric and magnetic field, only then it will not get deviated. Or you can think of it other way. If speed is given, magnetic field is given, then adjust the electric field such that this formula is obeyed. Only then that particle will go in. Now, where can you use this? Here, imagine you have electric field, imagine you have magnetic field, both are perpendicular. Electric field is here, magnetic field is here. And if you throw the charged particle here, and if the ratio of the speed, if the ratio of the fields is exactly equal to this speed, then the particle will not deviate at all, just like it is happening over here. In this case, this is no deflection. There is no deflection when this ratio is obeyed. For any other values of velocity, it will get deflected here or it will get deflected here, depending on whether the speed is more or whether the speed is less. That tells me I can use this as a velocity selector. Yes, imagine if I have a piece of cardboard here and there are holes made over here like this. All those particles which pass through this hole will have this velocity. All the particles which pass through this hole will have higher velocity. All the particles which pass through this hole will have lower velocity. So I can use this like a particle velocity selector. Do you understand it? I hope this is clear. Yes, it looks like a jail, prison, but anyways, I hope this is understood. I hope this is clear. So when electric field, magnetic field and velocity are perpendicular and this ratio is obeyed, only then there is no deflection. For anything else, you will always see some deflection. Okay, so yes, can be used for particle velocity selector. So let's now see what will happen. What will happen if you move a conductor inside magnetic field? Come on, let's think about it. Now, this is a conductor, very important. Keep this in mind. There are going to be plenty of questions on this, even in your booklets and even in JEE also you will see a lot of questions on this. So guys, imagine you move a conductor. You will be like, sir, in a conductor there is no charge on it as such, so there should be no force. Well, partially you are correct, but each particle on that conductor is made up of atoms, and atoms are nothing but positive and negative charges. Now the best thing is, if you move the conductor, say for example, I move the conductor here, example, what will happen? The protons which are there, which are moving here, they will experience a force V cross B upwards, and the electrons which are there, which are also moving with the conductor, will experience a force exactly opposite, downwards. Now, in a conductor, who are permitted to move? Protons, which are there in the nucleus, or the free electrons? Who can move? Yes, R, I will cover thermodynamics as well, don't worry. So what will move? Will protons move or will electrons move? Obviously, free electrons will move. That means the moment you move this, you know what is going to happen? You are going to see the electrons getting accumulated over here. And they are going to leave, they are going to ditch, they are going to do breakup. They are going to do breakup with their respective nuclei. सैया जी से आज मैंने breakup कर लिया. Okay, everybody understood? Now the moment this happens, you'll be like, sir, why don't all electrons go there? Guys, the problem is for the new electrons to come here, these electrons will be like, hey, we are already here, we are going to repel you. So that's why further flow of electrons will be stopped. Understand? Not all electrons will go there because these electrons will repel, and these positives, these bichara boys who are left, all these girls broke up over here and they went down. They're like, hey, wait, we are there too. Hey, we are going to attract you. Hold on, hold on. So that's why further flow of electrons is going to be stopped. Now, the moment this happens, you are going to see a potential difference. You're going to see a potential difference in that conductor. So just taking a neutral conductor and moving it in a magnetic field, you will see a potential difference across it. And by measuring the potential difference, you can figure out how much was the magnetic field. This was discovered by Hall, and that's why this is also called as the Hall effect. Alright, this is also called as the Hall effect. So potential difference created in a conductor. Alright, so basically don't need to understand all this right now, but understand a Hall effect is when, you know, separation happens, breakups happens within a conductor. A lot of electrons here, protons are here. So a potential difference is created. Measuring the voltage difference, you can measure how strong the magnetic field is, how strong it is. So it is sometimes used to measure the strength of the magnetic field. That is called as the Hall effect, by the way. Let's do a question on this. Hall effect. No, Pandus and Champas won't break up, don't worry. Pandus and Champa's love story bond is very strong. And even if they break up, they will again patch up. Acha, chalo. The cuboid is there of length L, breadth B, height H. Guys, remember this is a marathon session. We are going to continue for more than one more hour. Okay, I hope you guys are not getting tired. And I hope you guys are full on Josh still now. Alright. Okay, so it's moving in the x-axis in a magnetic field of B. Where is the field? Here. Find the potential difference across opposite faces of the cuboid. Let's do this. Let's do this. Velocity is there. Magnetic field is here. Use your right hand. Come on, everybody has a right hand. All right, all those people who have the right hand, please put your hands up in the air and dance like this. All right, very good. So, guys, velocity is there. Magnetic field is here. V cross B. Come on, do V cross B. Velocity is there. Magnetic field is here. Force will come down. Force will come down, guys. So, the force on the positive charges will be down, and the force on the negative charges will be up. I hope this is clear. So that means all the electrons after the breakup will be accumulated on the top face, and all the bicharas out here will be below. So guys, where is the potential difference created? Across the top and the bottom. So across the top and the bottom, of course. I hope you can see that. V was there, V cross B down. So between bottom and top. So is there Any potential difference between left and right? Is there any potential difference between left and right face? I don't think so. There is no breakup happening there. Is there any potential difference between front and back? Well, that is also zero. Front there is no charge and back also there is no charge. It's only top and bottom. So what is the potential difference here? That's what we need to find. Guys, think about it. Okay, so first two answers are done. Left, right and front, back are done. So now we need to figure out what is the potential difference between top and bottom. So what do? Think about it. Further flow of electrons was arrested. Why weren't the electrons able to move? Because understand, there was a lot of electrons already on the top and these positive charges were also pulling. I have a feeling this is like, you have created an electric field over here. Alright, you have created an electric field over here like this. Oops, sorry, it should have been up, my bad. The electric field has been created here. Electric field is here, magnetic field is towards you and velocity is there. Velocity here, electric field here, magnetic field here. What kind of fields are these? These are cross fields. Velocity there, electric field here, magnetic field here, cross fields. So guys, why aren't the charges inside moving or accumulating any more further? Because it's a balanced cross field. That means V will be equal to E by B. V will be equal to E by B. I hope this is clear, guys. Yes, exactly like velocity selector. And what is electric field? It is voltage difference. But in this case, it is between the top and bottom. E is equal to delta V by delta R. Delta R will be whatever is the height, which is H, divided by B. So therefore, understand, delta V between bottom and top will be speed B, and that H was below, so it will go on the top. That's the final answer. VBH, that's the answer. I hope this is clear. Ranveer, this is an English channel. So the whole reason we started this channel is because people were not able to understand Hindi, and now I cannot go back to Hindi. Alright, there is a separate Hindi channel, dear Ranveer. Okay, so you can definitely go watch there, or just like Ritu suggested, you can watch it at 0.75 or 0.5x. Alright, okay, let's get going. I hope everybody has understood how to solve this question now. So the next question, before we go there, again a small break. So some people ask me, sir, why do you talk about these crash courses and all that? Guys, it's just to make me feel comfortable, because I know what is there in these slides. So whenever I talk about comfortable stuff, so I also get little bit relaxed. I don't have to put too much of pressure on my mind. So I know what is there. So guys, yes, crash course for all of you who are in 12th, who are dropper students. Guys, this crash course starts every Monday and you get amazing master teachers. You have 120 sessions, live sessions, and 10 part syllabus test series, and unlimited doubt solving from morning till the night, and also amazing tricks and tip sessions by all our amazing master teachers. And also it's understand, it's a two-way learning platform. So you have the master teacher, you have the class teacher who help you out throughout the session. So all this starts every Monday, so you will not miss anything and you will be getting prepared for your upcoming entrance examinations. It's a crash course. So guys, the link is shared in the description box below, and the coupon code is also shared over here, SHCC. So when you use this coupon code, a miracle happens, a magic happens, and you get flat 20% off, and instead of 10,000 you get you have to just pay only 8,000 rupees, which is very nominal. I mean, if you buy some expensive books also, it will go more than that. Let me tell you. In fact, the material cost only will be so much more, guys. And 8,000 is negligible. All right. So let's get going. Okay, now let's talk about a very interesting concept. Now we are going to move to the second part, guys. Let's talk about the second part. Now, what is the second part? The second part is, imagine we have seen that charged particles, when they move in magnetic field, they experience force. Correct? We just saw that. When charged particles are thrown in magnetic field, they experience force. Now Pandu begins to think. So Pandu is thinking that what now when you have a current carrying wire, and in a current carrying wire also charges are moving. And what if I take a current carrying wire inside a magnetic field? Shouldn't something magical happen? Shouldn't something magical happen, guys? Yes. And because a current carrying wire is nothing but at the end of the day moving charges, so if you take a wire carrying current and putting in a magnetic field, even that wire will be pulled because or pushed because of that magnetic field. So we are going to see what is the formula for that, and let's begin. So I'm going to give you some amazing theorems as well out here which will help you solve the problems. So if you have a wire, all right, whose current flowing inside it is I, and the length of that wire is L, and the magnetic field of course is over here is B, then the force acting on that wire is given by I L cross B. This is the value of that force. You should remember this. Now you might be thinking, sir, but what is the direction of L? Because L is length. So the direction of L, alright, so the direction of L is same as the direction of current. So that's what you should take. As simple as that. Now in this case, assuming the current is going here, so current is there, so length is there. Length cross B, length is there, B is inside. Come on, everybody use your right hands. L cross B, where does it come? It comes here. So the force acting on this will be over here. Understand that. So the force acting on that will be over here. Now, there were various experiments done like this. You take a wire, okay, you take a wire, guys, and you have, let's say, magnetic field this way, let's say coming towards you. So there is magnetic field coming towards you. Now imagine in this wire the current is going up. Imagine in this wire the current is going up. Do you think this wire will bend somewhere, either left or right or front or back somewhere? Let's try this out. I is going up, that means length will be on the top. B is towards you, so it's on the top, and B is coming towards you. L cross B will be this side, so the force will be here. So this wire will bend like this. It will bend like this. If you actually do this, it will actually bend. And if I reverse the direction of current, yes, if you reverse the direction of current, then length is below, B is towards you, length cross B, it goes there, it goes there, length is below, B is there, it goes there, so the wire will bend like this, that way, and it can be seen. And you pass more current, more force will be there, and it will bend even more. That's what happens. Interesting. Ranveer, it's not about just being famous. Yeah, I just want to teach, and you need all the subjects. Remember that. Just physics is not enough. You need physics, chemistry, maths, all three of them, and all three of us are here for you. Okay, don't worry. So this force is called as Lorentz force. Saurav, this is only Lorentz force. Now in 9th and 10th, I know there is one ridiculous way of doing this. Fleming's left hand rule, Fleming's right hand rule, Lorentz left hand rule, Lorentz right foot rule, and then somebody else's left foot rule, and then somebody's waist rule. Oh my god, it is so crazy, guys. It's so crazy. I don't even remember which is left hand, which is right hand, when to use what. It's crazy. So guys, do not use all these stupid rules. Please don't use all these stupid rules. It's crazy. So just use right hand rule every time. You will not get confused. I, L cross B. Just remember the cross product, guys. How difficult is it to just move your 4 bloody fingers? Yeah, just move your 4 fingers. That's it. What more you want? And remember this formula. Don't have to remember. Acha, this is I, this is L, this is B. Oh, in EMI this is different. Oh, this was this, this was this, this was this. You look like a retard out there completely doing all this. in the examination hall, the examiner will think you are a retard. He will probably send you to the retarded section. So don't do this. I hope this is clear. Okay. Okay, so let's do a question. Let's see how many of you can do this question. Very interesting question, guys. So find the magnetic force of the current I carrying loop on each side. Magnetic field is B in the X direction. Oh my God, X is here and B is in the X direction. Okay. Let's do this. So let's just mark where our magnetic field is first. The magnetic field is over here. Okay, let's keep this in mind. This is B. Okay. Now the current is going like that, so I'll just mark the currents in every branch so that I do not face any difficulty. And it is like this and like this. Okay, I hope I'm correct now. Okay, so this current is iron. Let's do this, guys. Come on. Everybody with me. All those people who have their right hands up in the air and shake it. All right. Okay, so first let's start with the topmost wire out here. Let's start with the topmost wire out here. Come on, everybody. So it's going in this direction. That means it's coming out of the plane of the board, guys. L cross B. Remember the formula. Formula is IL cross B. Look at this, guys. L and B both are in the same direction. The force is 0. So this is 0. In fact, this will be also 0. Check this out. This is 0, this is 0 because L cross B will be 0. Parallel, anti-parallel does not matter. L cross B will be 0. Yes, I hope this is clear. Okay, now let's talk about this part. Okay, now length is below. Come on, length is below. B is out of the plane. Come on, everybody do this. Length is below. B is out of the plane, so I think I should move my fingers like this. It goes that way. Check it out. L is below. L cross B. It goes towards minus Y. Check this out. It goes like this. And the value will be I. Length is A and B. That's the answer for this. It goes along minus Y direction. I hope this is clear. Now go for this. Length is there, magnetic field is there towards you. Length cross B, it will go down. Check it out. Length cross B. Okay, length cross B, it will go down. Just check it out. Okay, just check it out. Everyone fine till here? So it will be I, A, B. Is that clear? By the way, these are JEE advanced questions, and after completing this question, I will give you a 5-second trick after which you can solve the entire problem within 5 seconds. Yes, with the directions. 5-second trick after this complete arrow marks and the values. Hold on. Now this is done. Let's talk about this. Length is there. Okay, length is there and B is here. L cross B. Oh my God. L cross B, it's up. Okay, so it's here. I cross B. So it will be I, A and B, of course. Lastly, only this part left. Length is on the top. B is towards you. Length cross B. So length cross B. Come on, do this. So you should get this one. So it should be I, A, B again. Did you see the amount of circus I did for doing this problem? From where and all I went, what and all I did. Such a circus it was. Guys, there is a simple way of doing this. Now, what you can do is, remember, whenever you have a loop and there is a magnetic field, uniform magnetic field, if you find the direction of force on any one side, then all others automatically come outwards or inwards automatically. If one is outwards, all others will be outwards. If one is inwards, all others will be automatically inwards in a uniform field. Remember that and it will help you solve the problems. Yes, so just remember this. Okay, so remember that, and in case the entire thing was in the same plane, then use this trick. When they are in two different planes, you need to be a little bit careful. Okay, so be careful about it. Okay, chalo. Now let's get going to the next question. I solved this question with a lot of circus. By the way, chalo, let's do this question, guys. Here, oh, this is a trick, by the way. If there is a curved wire, then how do I find the force? Because each part will experience forces in weird directions. Remember, once I know the force on any one part, if it is out, it will be out on every other part. That's the trick. Okay, now I have to sit and integrate, right? It will be such a tedious task. No need to integrate. Whenever there is a curved wire, what you do is replace it with a straight wire. Replace it with a straight wire, and whatever force acts on that straight wire, is the force which acts on the curved wire. As simple as that. So the force on the curved wire is the same as the force on the straight wire, obviously carrying the same current. So if the current in this wire was I, this current should also be I, and that is the answer. As simple as that. So no need of integration. As simple as that. Is it clear, everyone? So this trick will be useful many places. Imagine if I have a complete loop. So then what is the starting point and ending point? This was the starting point, this was the ending point for an incomplete loop. For a complete loop, the starting and the end are same. So what will you replace it with? You will replace it with nothing. So what will be the force on nothing? 0. So the force on that loop will obviously be 0. I hope this is clear. Yes. Very interesting. Okay, let's do this question. Let's see how many of you can get this. In a semicircular current carrying loop, it is placed in a uniform magnetic field of 1 Tesla as shown. If the radius of the loop is 1 meter, then the magnetic force on the loop is how much? Come on guys. Come on everyone. Let me have my little hearts. Giri, only the starting point and the ending point should match. That's it. It's not a complete loop. Only the semicircle. Be careful. It's not complete loop. Be careful, guys. It's not the complete loop. Only on the semicircle how much force will act. It's not completed. Be careful. Yes. Let's see what the correct answer is. Okay. The answer is given to be 8 Newton. I think it should be different, but let's see. I don't know. We'll solve it and see what the answer should be. So, a semicircular current loop, only this much part is not there, okay, is placed in a uniform field of 1 Tesla. Now this loop can be replaced by just a straight wire, and it carries the same current. How much current? It's given, I think. How many amperes? 1 Tesla is shown. The current, yes, it's 2 amperes. Yes, it's given here, 2 amperes. So the force on that semicircle will be same as the force on the diameter, which joins the start and the end, and it is nothing but I, L, B. So what is I? 2. What is L? This diameter, the radius is 1 meter, so diameter will be 2. And what is the magnetic field? It is 1. So it should be 4 Tesla, guys. 4 Tesla. It's not 8 Newton. I think it is option A, which said 4 Newton, if I'm not wrong. Yes, that's the not 4 Tesla, my bad, 4 Newtons. That should be the answer. It's not 8, it was wrong. I thought so. It was a printing mistake, don't worry about it. It is 4 Newton. I hope this is understood. No problem, VK channel. Okay, I hope this is clear. Shall we go ahead? Okay, let's go ahead. Next question, coming up on your screen. A loop, this is a complete circular or whatever, square loop, is carrying some current and it is placed in a uniform magnetic field. Then which of the following is possible? which of the following is possible? Come on, think about it. Which of the following? Multiple options may be correct. More than one may be correct. More than one may be correct. The current value DME was given on the diagram itself. 2 amperes was mentioned on the diagram. Okay. All right, all right. Okay, what do you guys think? A and B, A, B, C, D, A, B, D. Okay, A, B, D, Villiers. Okay, so the correct answer is only A and B, guys. The correct answer is only A, B. Now you will be like, why is it only A and B? See guys, think about it. Since it's a complete loop, the start and the end are the same. So what will be the L effective length? That will be 0. So the force on it has to be 0 in a uniform field. So the force has to be 0. So obviously C and D become wrong because here force is mentioned to be not 0. I hope this is clear. Now, only problem is for the torque. Will torque be there or will torque not be there? It depends on the orientation of the loop. It depends on the orientation of the loop. Nothing as such has been specified. A loop carrying current is placed in a uniform field. Then will the torque be 0 or not 0? Depends on how it is oriented. And now we are going to see how to calculate the torque on a loop. Don't worry. Okay, so we're going to see how to calculate the torque on a loop. Now to do that, to find the torque on a loop which carries current, which is placed in a uniform field or non-uniform field, understand this principle is used in motors. All the motors work on this principle. Yes, just Lorentz force. So there is a coil, there is magnetic field. When current passes through that coil, there is a torque and that coil rotates. And that's it. It rotates the shaft and whatever, it drives your wheels. That's how electric cars work. Electric motors are based on exactly this principle. Exactly this principle. Now, how to find that out? Before that, we need to first understand what is magnetic moment. Do you remember electric dipole moment? We have studied this in electrostatics. Same way, there is magnetic moment. It's exactly similar. It's exactly similar. All right. By the way, oh yes, somebody said this looks like a generator. I'll tell you something surprising. Generator and motor are almost the same thing, guys. If you pass current, it will rotate and it will give you power, mechanical energy. That is a motor. But if you rotate it without providing current, then current will be generated inside it. It will act like a generator. It's the same thing. Try it out. You take a motor, rotate it with your hand, you will see a bulb glowing if you have connected wires. And you pass current in the same motor, it will rotate it. Very interesting. Okay. By the way, you need to constantly change the direction of current. So there are a lot of things, brushed motor, brushed, and sometimes you have those slip discs and all those things. So there are different arrangements through which you can change the direction of current, and sometimes you can even use AC current to change the direction and stuff like that. But that's a detail you'll be studying if you take electrical engineering and stuff like that. Okay. Now, no problem VK, see you tomorrow. Looks like VK stamina is over, but all the other minions, I know the stamina is still there. All right. So what is magnetic moment? Exactly like electric dipole moment, guys. Imagine if you have a wire which carries current. Okay, if you have a wire which carries current, it behaves just like a magnet. Yes, with north pole here and south pole here. What is this? Two poles of a magnet, dipole. So that's why magnetic dipole moment. That's the name why it has come. So if you have a current and there is some area enclosed in it, the magnetic dipole moment is given by a direction using your right hand. So curl your fingers in the direction of current. The thumb points in the direction of magnetic dipole moment. And what's the formula for it? M is the symbol, by the way, is N-I-A. That's it. That's the formula. Now I'll explain to you what each term is. First, N. What is N? N is nothing but number of turns. And it makes sense. If you have more coils, more turns, the magnetic strength will increase. This magnet will become stronger. So magnetic dipole moment depends on the number of turns. I is obviously current and A is nothing but area. But I have put a bar over there. It's an area vector. How do I decide the sign of the area vector? Using your right hand rule. So using your right hand rule, you can get the direction of area vector. And this is nothing but your magnetic dipole moment, and some books use the symbol mu, okay, but I am using the symbol capital M. That's easy to understand. And the unit, what will be the unit, guys? Think about it. N is just number of turns, so no unit. Current is amperes, so amperes is there, and there is meter square. So ampere meter square is the unit of magnetic dipole moment. I hope this is clear. I hope this is clear. So very important. So a coil carrying current is nothing but a magnet which has two poles. So it has magnetic dipole moment. As simple as that. And it is given by NIA. NIA, National Investigation Agency. So remember that. Already I have told you about another company in current electricity, NVIDIA. So today you are learning about NIA. Okay, great. So imagine now an electron is orbiting a nucleus. An electron is orbiting the nucleus. Can I think that the electron in that orbit is just like a wire carrying current? There's no difference. Think about it. It's an equivalent wire which carries current. So won't it also have a magnetic dipole moment? Just because the charge is moving in circular path or in orbit, it's like a current carrying loop, so it should also have a magnetic dipole moment. So you would have studied this in chemistry, physical chemistry or atomic structure, that an electron orbiting an atom or a nucleus basically has magnetic dipole moment. So what is the magnetic dipole moment of an electron orbiting? We can figure this out. It's not that difficult. Now, how to do this? So this electron, remember, is a negative charge. So it is going like this. Electron is going like this for you clockwise. But remember, current is the flow of positive charges. So the current will be taken this way. Understand? So the current will be taken this way. And if you curl your fingers this way, thumb will point up. That's why north pole is up, south pole is down. And the magnetic moment is upwards. I hope this is clear. That's why electron and currents both are in the opposite direction. Now, ideally speaking, okay, if I had to find, how much is the equivalent current, I will do it like this. Current is flow of charge upon the time taken. Now, how much charge flows in one complete circle? That's nothing but the electron charge. How much time does it take? Well, I don't know, but it's just a time period. Okay, and what's the time period? Time period is 2 pi by omega. So omega will come on the top. So this is nothing but the current flowing through it. I is nothing but, or I'll just put it small I so that you don't get confused. This is small I. Current is charged into omega by 2 pi. Now once I know I can find the magnetic moment. Magnetic moment will be number of turns is 1 because I took only one time period. I is I into area. Now I is E omega by 2 pi. And what is the area? Pi r square. Because it's a circular orbits area, enclosed area will be pi r square. So that is the magnetic moment. I hope this is clear. I hope this is clear, everyone. Come on, show some support if you guys have understood this. But you know what? This is not the complete answer, because what is the radius? You have to recollect that formula from atomic structure then. What is omega? You have to again sit and derive. So this method reaches a very critical stage where you have to do a lot of stuff after this to find the magnetic moment. This is good if it was not an electron, if it was just a charge orbiting, then you can stop over here and give the final answer. But the moment there is an electron orbiting a nucleus, I can use a very special thing. Understand, I'm going to give you a magical formula. That magical formula is this. Magnetic moment by angular momentum is always charge by 2 times of mass. This is very, very important formula. This is a trick which you can use every time and it will always save you lot of integration, lot of calculations. How? Check this out. Understand, M will be, magnetic moment will be angular momentum into charge by 2m. Now, if you recollect, in atomic structure you would have studied angular momentum is nothing but nh by 2 pi, where h is Planck's constant, n is your principal quantum number. Have you studied this? So it was your principal quantum number, guys. H was Planck's constant. Haven't you studied this? So just substitute. So L is angular momentum. So it is nh by 2 pi into charge is E and 2 into m. That's it. That's your final answer and we are done. I hope this is clear. This is clear. That's it. That's the final answer. That's the magnetic moment. That's it. Final answer. Done. So this formula will save your day. Okay? Remember this. Nothing extra you need to do. All right. Now L was angular momentum. Please understand that this is magnetic moment, this is charge, this is mass. Okay, let's do a question on this. Now this question is done in many books in many complicated ways. This is a charged disk. Okay, this is a charged disk and there are a lot of charges on it, and because you are rotating it, each charge is going in a circle. Now because of that, it's like a current carrying loop, but there are many loops. Imagine there are infinite small current carrying loops. So because of which there will be a magnetic moment. Each loop will give a magnetic moment, guys. Now to find that total magnetic moment, do you understand the amount of circles we need to do? We need to sit and integrate. But we are not going to do all that business. What are we going to do? Use our formula. What is our formula? M by L is Q by 2m. That's it. So M will be equal to L. L is nothing but moment of inertia into omega, correct? And Q is Q, M is M. What is the formula for moment of inertia of a disk? It is mr square by 2. Omega is omega. Q by 2m. Mm gone. Mass has no value only. Okay. R square omega Q by 2 into 2, 4. That's the answer, guys. How many seconds did we take? Did you understand? Did you understand how simple it is? Did you understand, guys? So simple it is, no need of integration. Use this magical formula, it will help you. It will help you. All right. Daimi, what request? Satya, what request? Give us DPP of this chapter to practice. Daimi, I am going to conduct, and Satya, we are going to conduct a Menti quiz next week on this chapter. So that will be like a practice. Plus, every chapter or every lecture, I give you homework questions. 1 or 2 homework questions, and if you want lot of daily practice problems, then of course our crash course is also there. Okay, great. Chalo, let's get going. Okay, now last few things. Don't worry, I know it's 8:45, but we are going to do it. Come on, guys, little bit more. Come on, buckle up, drink some water. Come on, chalo, thoda sa pani pee lo. Drink some water, drink some juice, move your hands, stretch your body, move your neck. Alrighty. Yes, Khushbu, why not? Have some biscuits, have something. Come on, I'll eat it for you. If you are not going to eat, I'm going to eat it for you guys. Come on, do this. Sneha, grab something. Stravanan, very lazy fellow. Wow, Jumna, so lucky, yeah, you are getting feeded by your mom. So cool. Hey, Selva, even I had dosas in the morning, yeah. Chakra restored. Science Priyato had dinner only. Aishwarya is having cookies. Very good. Stravanan, I hope you'll watch the replay later on. Thank you, Princey. Very good, very good, very good, very good. Chalo, let's get going. Let's get going. Let's get going. So, remember I was telling you, if there is a loop in a magnetic field, then the force is zero, but torque may or may not be zero. Remember that? Now, I just introduced what is the magnetic moment of a loop. NIA, National Investigation Agency. That's a way to remember it. Okay. Now, the moment you place a loop in a field, then there is a torque acting on it, and that torque is given by this formula. So if this is a loop which carries some current I, and this is the magnetic moment, okay, so this is the magnetic moment, and the field could be in any direction. Let's say in this case the field is like this is the angle between that, then the torque acting on it is given by M cross B. Now this reminds me of the good old days of electrostatics. Torque acting on an electric dipole, what is it? P cross E, guys. Do you see the similarity? Do you see the similarity? Instead of electric field, magnetic field. Instead of dipole moment, electric dipole moment, magnetic dipole moment. Same thing, guys. Nothing different. Nothing different. And what is this M? This M is NIA. That's it. So that's the torque acting on it. Now you can see that since torque is M cross B, so the magnitude will be MB sine theta. So if you change theta, even the torque will change. So you can see the torque will vary depending on the angle between the magnetic moment and the magnetic field. You can see that. You can see that. No problem, Sunil. You can definitely do that. You can definitely do that. No problem, Khushbu. Anytime. Okay. Now, there is one more formula which I can recollect from my previous sessions, and you would also remember it. And that is nothing but potential energy, guys. Potential energy formula, remember, in electric field was minus P dot E. But here it will not be P dot E, it will be minus M dot B. That's it. That's your potential energy formula, because when you change the orientation, it has some energy. Because of the torque, it can restore itself. It's like a spring. When you twist it, it has some energy. So the energy stored is minus M dot B. But when we do that, understand the potential energy is zero when, alright, so when theta is how much? 90 degrees. So that is your reference. So energy is assumed to be zero. Just like for potential energy, you take a block, you assume that here the potential energy is zero, here it is mgh, here it is minus mgh. Same way, when the angle between magnetic field and magnetic moment are 90 degrees, then it is assumed to be zero. Remember that. All right. All right. Sunil, there is no problem, yaar. Sunil, I'll tell you, when did I start preparing? I started preparing in 11th. I still cleared now. Many of my friends joined in 11th, they cleared. So don't worry. There are people who will prepare even when they are born, yaar. So will you get worried because of that? No, right? Enjoy, man, chill, and you can always do that. Don't worry, you're not wasted anything. There is a lot of life left. Be motivated, stay with us, we'll help you, okay? All right. Now, the last thing over here, after this you're going to see some questions on this. This kind of table, we also made it in electric dipole. Now you'll see a similar table over here. If you have North Pole and South Pole, aligned in the direction of field. This is B field, magnetic field. You can see that over here theta is 0 degrees because the magnetic moment is in this direction and magnetic field is also in this direction. Here you can see that the magnetic moment is over here. All right, this is the magnetic moment's direction. So here theta is 90 degrees. And in this case, you can see the magnetic moment is opposite. So theta is 180 degrees. You can see all the three variations. Can you guess the torque in the first case? Think about it, M cross B. Remember, torque is M cross B. Obviously the torque will be 0, guys. You can see that. The torque will be 0. Cross product will be 0. Both are parallel. Here, M is perpendicular to B. MB sine 90. So MB sine 90, which is just going to be M into B. In fact, this is going to be the maximum torque. Beyond this, you cannot get magnitude-wise. Here, M and B are opposite. So again 0 because sine 180, since sine of 180 degrees is 0. This is the torque. Let's talk about energy, guys. Energy, recollect, potential energy was minus M dot B. Be careful. First case, M and B are parallel. So MB cos 0. Cos 0 is 1. So it will be minus MB. Understand, MB cos 0. Cos 0 is 1. That minus came as it is. When it is 90, it is obviously 0. Cos 90 is 0, guys. It's a dot product. Be careful. This is a dot product. And lastly, when it is opposite, what is cos 180? Cos 180 is minus 1. Minus 1 into minus 1, what will happen? Plus 1. So it will be plus MB. Do you see? This is the minimum energy minus, and this is the maximum energy. You can see that. Clearly you can see that. I hope this is clear. Last thing over here. So Khushbu, there are two ways. One is you put it in the comments. Second is you message on Instagram. Third is you are a pro user, then you can ask doubts over there. Very good, Ankit. Keep making notes. Yes, guys, please keep making notes. Just don't keep chatting. I know chatting is essential. It will boost your morale and your, you will feel comfortable and you will feel lively. Yes, keep chatting, but at the same time also keep making notes. Hello, Ganesh Babu. Welcome, 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 Ganesh Babu. All right. So, equilibrium. See, guys, the torque is 0. When the torque is 0 here, okay, this is obviously an equilibrium. Here, the torque is not 0. In fact, it is maximum. So there is no kind of equilibrium at all. Here again, the torque is 0. So there is again an equilibrium. But which kind of equilibrium? Think about it. If I move it here slightly, this magnetic moment, field is still there. M cross B will pull this down. So if I move the magnetic moment here, M cross B will pull me down. If I move it down like this, M cross B will pull this back here. So I'm always coming back to the same point. That means this is nothing but stable kind of equilibrium. Over here, M is opposite. M is this way, guys. M is this way. Think about it. B is there. If you slightly move it here, then M cross B will push it here. M cross B will push it here. And if you slightly move it down, then M cross B will again pull it here. So a small disturbance here or there will completely push it away from that point. So this is obviously unstable equilibrium. Very important. Very important. All right. I hope this is clear. Thank you, Science Priya, for helping out. Excellent minions. Excellent minions. Very important table. This will be all coming in the extracts as well. Remember, those are my notes in printed form. Okay. Remember that. So, by the way, for all the people who want to get their doubts solved or who want a lot of assignments, who want a lot of DPPs, who want a lot of, revision, etc. The crash course is still there, runs every Monday, starts every Monday, and it will continue till the end of, February, March, whenever your JEE Mains exam is. You can check out all the details below and you can use this coupon code for getting 2000 rupees discount. Okay, let's do this question. Come on, guys, do this question. Come on, come on, come on, come on, come on. Read it. Ranveer, complete it. Don't leave center of mass. It's very important. Guys, 2 more questions and we are done for today. 2 more, just 1 more question after this. That's it. All right. Yes. Jagdish, put in the comments. I'll help you out. I can't give you the answer in 1 line. After the session is over, put it in the comments or ping me on Instagram, Shreyas_Vedantu. All right. Let's see what the correct answer is. Okay, the correct answer is 90 plus theta. Now, why is it 90 plus theta? Let me tell you. See, this is a loop. It carries current. The loop can rotate about xx prime and this makes angle theta. Now if that makes angle theta, then even this is theta. Okay, opposite angles. Then through what angle will the loop rotate by itself before the torque on it becomes 0? Okay, you know what is the best thing to do? Don't sit and visualize it in 3D. Just draw the top view diagram. This is always going to be helpful, guys, in many situations. Whenever you can't visualize in 3D, draw the side view, front view, top view, any view which will help you or benefit you understand the problem. So when you look at it from the top, you are seeing it from the top like this. What you are going to see is you are going to see the z-axis. All right, the z-axis here. Okay, and you are going to see the y-axis here, and you are also going to see, okay, you're going to see that loop, okay, that loop like this, that will be the loop, and this will be angle theta, and this will be also angle theta. I hope you can see that. Now, if you're able to visualize this from the top, just think, because the current is going like this, curl your fingers in the direction of current, you will see the direction of magnetic moment. It is going that way. That means the magnetic moment, when you see it from the top, will be this way. I hope this is clear. You're seeing it from the top, guys. Understand the magnetic moment is coming here, so it will be that way. Now all you need to do is, where is the magnetic field? Magnetic field, uniform magnetic field. Oh, it's in the z direction. The magnetic field is in the z direction, guys. Now think about it. What angle should it rotate so that by itself, very important, by itself, not by external force, so that the torque becomes 0. What will be the torque? The torque will try to pull this M in the direction of B. So guys, can you just think about it? How much will it rotate? Because if this is theta, this is also theta. Do not forget, because this is 90 minus theta. Remember, this was perpendicular. This was also perpendicular. So how much should it rotate? Theta plus 90. Hence, that's the answer. Isn't it interesting way to solve? Not even one equation I wrote. Not even one. It's just visualization. And visualization through proper way. If I looked at it from here, it would be very difficult. I looked at it from the top. So try this technique out for 3D problems. It helps you. Yes, I hope this is clear. Very, very important problem. This word itself makes a difference. If this word itself was not there, then you can just rotate M by only this much angle and you can make the torque 0. Yes, but that is not by itself. You are forcing it, because the torque will always try to pull it here. Remember that. Okay. Now, this question, come on, try this out. Oh yes, this is the last question. Come on, guys. There is a loop of radius r having 10 turns carrying current I. It's placed in a uniform magnetic field Bi cap. The current is clockwise when seen from the positive side of the x-axis. If the loop is turned about the y-axis by 180, what is the work done? Beautiful question. Manish, maths is very important, not just for JEE, Manish, but even in life. lot of people think maths is just a subject, but no, maths is just important in everything in life, be it economics, be it arts, be it even music. Everything around you is because of maths, understand that. So please give importance to maths and try to understand the practical application of it. Only then you will enjoy maths. So even I used to get scared of maths, but my teachers were very good in school and they told me practice a lot of problems. I just kept on practicing problems and slowly I started understanding, and that's it. Okay. Very good, यश, बहुत बढ़िया, एक नंबर, excellent है. हाँ, Saurav, be careful. The work done by magnetic field is 0, but understand there is potential energy because of the torque. Okay. You should focus on JEE, Ankit, obviously, no doubt about it. Alright, so let's see what the correct answer is. Now again, look at it from the top, things will be very easy. See guys, the loop, when seen from here, the current is clockwise. So the current is going like this, clockwise. Okay, the current is going like this. That means the magnetic dipole moment should be here. This is where the magnetic dipole moment should be. Okay, great. Now, where is the magnetic field? The magnetic field is here. Acha, M and B are opposite to each other. M and B are opposite to each other. So B is here. Now think about it. If the loop is turned about the y-axis, that means what is happening? If you look at it from the top, so from the top, this is what you're going to see. B is here. B is here. All right. M was here. And you rotate it by 180 degrees and place it here. So guys, think about it, potential energy will change. Understood? The potential energy will change. This is initial, this is final. What is the initial potential energy? Think about it, minus m dot b. If you have forgotten, I'll write it here. Minus mb cos theta, guys. So when it is opposite, cos 180 is minus 1, minus minus will become plus. So plus mb when it is opposite. I hope this is clear. Minus 1 from the cos and minus 1 from here. So minus minus becomes plus. And when you turn it here, what will be the answer, guys? M and B are in the same direction. Cos 0 is 1. So it will be minus MB. So guys, what is the change in the potential energy? Final minus initial. Final minus initial. Minus MB minus MB. Which will be how much? 2 MB with a negative sign. Minus 2 MB. Very interesting. Very interesting. So the change is 2 MB. Lot of people forget that minus sign and they think, oh, it is MB here, oh, it is MB there, difference is 0. No, the difference is 2 MB. So where will this energy change come from? Where will it come from, guys? How will the potential energy change? Because of the work done by the external force. So that's it. How much is the work done? Minus 2 MB. That's the answer. That's the work done. If you do work, only then the potential energy will change. So whatever work I am doing will be the change in the potential energy. That's the answer. I hope this is clear. So these are our stars of our previous sessions who have posted the answers in the comment box below after the session is over. Very good, Aishwarya Gandhi, Dinesh Kanan and DMS Kids YT. Very good, very good. So guys, if you're going to post the answers of these two questions in the comment box, I'll be posting your comments in the next video. So this is your first homework. This is your first homework and this is your second homework question. You can take screenshots of this question and this question as well. Take the screenshots, guys, of these two questions. All right, and I'll be posting the solutions on the Telegram group. So join the Telegram group if you have not joined it yet. Please do that, and a lot of important updates, notifications will come over there. And also like the video today, guys. I stood here for all of you for so much time, and tomorrow morning I'm going to meet you at what time, guys? 8 o'clock. For what session? KVPY session. Which topic? Electrostatics, current, electricity, all those things. All right, so see you guys tomorrow. Take care, have a good sleep, and keep rocking, guys, as usual. And do not forget to hit the subscribe and like button as well. Bye bye. This was Shreyas here, your master teacher for physics at Vedantu, who was going live from Bangalore. Bye bye.